Good afternoon, everyone, and welcome to the Hydrogen and Fuel Cells Europe here at the Hannover Messe 2023. We're here at the technical forum where we dive into all of the little technical details in the hydrogen sector. Please have a seat, have a drink. The drinks are on the house, and the lovely hostesses here are here to help you get them. All right, up next, brazing or 3D printing. No, heat exchangers for hydrogen station made by diffusion bonding. I have here today from Welcome the sales manager. Please welcome to the stage Kiyohiko Matsubara-san. Thank you.
Thank you very much.
Thank you for joining us.
Yes. Thank you for introducing me. Yes. I'm Kiyohiko Matsubara from Welcome, in charge of the director of the sales department. I'd like to let you know today the basic our company's overviews and our technology. The title is Brazing or 3D printing? No, yes. Heat exchangers for high hydrogen station made by diffusion bonding. So go on the next page. Let's get started. So our company is located in Niigata City, Japan. Niigata is north side from Tokyo, on the 350 kilometers north side of Tokyo. We can provide one-stop service from prototype development to the mass production, like this. Our product reflects our core competence. The first is the thermal and fluid design technology. The second is the diffusion bonding design technology. The last one is the realization of 3D microchannel structure. So please go to the next page. We implement fine structures in products by diffusion bonding. Diffusion bonding makes it possible to manufacture products with three-dimensional channel structure, a three-dimensional hollow structure that is difficult to make by ordinary machining, like drilling. I introduce our three representative products here from the left. The first is a heat sink for cooling heat sources like semiconductors or high-power CPUs in an artificial server or supercomputer server. Second is a middle heat exchanger between fluids temperature difference. And the last one is the right side, vapor chamber. We call this vapor chamber was heat pipe for transporting and spreading heat from its small, tiny heat sources. Our products have a fine flow path structure called microchannel. The diameter is between hundreds micrometers. In our design, we expand heat exchange area by three-dimensional microchannel structure to enhance heat exchange efficiently, and as a result, downsize the product. First, I try to explain the basics of diffusion bonding process and its phenomena. Diffusion bonding is a method of material bonding, differing from welding and brazing. The bonding process is the first, place metal lamination in vacuum and chamber. Second, set heat and pressure conditions. Third, process time depends on number of metal layers, material, and size. And the last, finally, disappear each interface boundary in lamination due to diffusion bonding phenomena. you can see the original interface here. We intentionally stopped the process, and the original interface you can see slightly in this picture. In reality, this kind of boundary disappears perfectly. So I illustrate the process from this page. First, stack microchannel processed metal plates. The number of layers can be stacked more than 1,000 plates and bond simultaneously, even if the plate thickness is different. Set in vacuum chamber, and then apply the compression, the pressure, making close contact by compression. By applying energy heat, which causes atoms migration between interfaces. So finally, unified multiple layers, solid-state bonding does not cause metal melting, which contribute to make microchannel structure. We do not melt, or there is no grooves. Our products made by diffusion bonding have features and benefits like this. First, tensile strength is same as the mother material. Second, enable to fabricate products by stacking thin layer plates. And third, and enable to create complex three-dimensional hollow microstructure. And also possible for bonding with different materials combination, like aluminum and copper. I show you one example of our products. Heat exchanger, biotechnology, we can realize products with these features. One, no brazing materials used. Second, high pressure resistance, for example, 100 megapascal at normal operation. And furthermore, 4 times equals 400 megapascal or more at proof testing can be achieved. Third, surface area expansion, compact size, which contribute to reduce the amount of refrigerant used. Nowadays, heat pump systems are prevailing in Europe, and we can contribute the lower uses amount of refrigerant in such systems. The last finally, the pressure loss can be optimized by our channel design. This is an example, microchannel example. Yes, this flow path diameter is 250 micrometers. I show you one example of our products, a heat exchanger for hydrogen station dispenser, also known as precooler, right side. When refueling hydrogen to fuel cell vehicles, the supply pressure is defined as 87 megapascal. So the hydrogen needs to be pre-cooled to prevent tank malfunction by heat from abatic compression. Our precooler have features of first, compact high-performance heat exchanger for hydrogen station. The second is 1 million repeated withstand pressure test at 100 megapascal is cleared. Third, long-term resistance to hydrogen exposure. And last, Pressure Equipment Directive, PED, the CE marking here, Europe certification, and North America, ASME, approved. Yes, that's all for my presentation. Please come drop by the booth F22. Yes, please. Yeah, thank you very much. Yes, yes,
Thank you very much,
yeah.
Kiyohiko-san.
Yes.
Thank
Yeah,
you.
yes.
Thank you for sharing this. I believe it's confidential information with us.
Yes. Thank you.
Are there any questions from the audience
Wow,
at the
10
moment?
minutes.
So, Kiyohiko-san,
Yes.
if you had to sum it up in one point, what's the main benefit of using diffusion bonding instead of all of these other manufacturing?
Brazing? Okay. Diffusion bonding, yeah, it's a structure contribute to have the features of very strong. So in the hydrogen world, hydrogen needs to be compressed by reaction and or exchanging efficiency. So our heat exchanger has features of such exposure and pressure resistance. Yes, and yes, yeah.
Yeah, so with the diffusion bonding, it becomes a lot stronger, which is required for the super high pressures that we use for hydrogen.
Yes, right. Yes,
very clear.
Yes.
All right. Thank you very much for your presentation.
Thank you. Yes, thank you very much.
Yeah, everybody, please visit Kiyohiko-san at what was the booth again?
F22.
F22.
Yeah, same as Takaishi-san.
Yes. All right. Thank you very much.
Yes, thank you. Yes, thank you.